Okay, let's start. So, good afternoon, good evening, everyone. My name is Suresh, and I'm going to walk you through a live demo of AWS Observability solution. I work as a senior solutions engineer with Sumo Logic. I'm based out of Bangalore. Before we get started with the AWS Observability demo, let's look at few housekeeping items. Post this demo, we will be sharing this recording with you, and there is a Q&A button in the webinar. Please click the Q&A button and then raise all your questions there, and I will answer all those questions post the live demo. So let's get started. So to begin with, let us see what is the observability. At a higher level, observability is the ability to observe an application from the outside and to understand what is happening inside the application and its services. So I would say this is a simple definition of the observability. And why do we need observability? Because the observability helps us to ensure that the application is running, it is up, it is available, it is performing to the maximum of its capacity, and it is completely secure. So this, I would say, is a very high level, I would say, definition about observability. And then why observability is becoming important and why is it difficult to achieve? The predominant reasons being the modern applications are increasingly become more and more complex as new technologies are getting introduced. There are distributed technologies, we have containers, we have orchestration tools, we have cloud infrastructure where most of the organizations are moving applications to the code, and the organizations are also looking at delivering the code faster to the customers. So all this is making the applications much more complex. In addition to the complexity introduced by the microservices, the relationships, the connections between the microservices, the orchestrators, the underlying cloud resources, all of them are actually increasing the complexity of our applications under the infrastructure. And what's happening because of this complexity? It leads us to situations where unforeseen events, the unknowns which are happening in the infrastructure as well as on the applications. So these introduce risks, these introduce downtimes, and it becomes increasingly difficult for us to diagnose this mysterious behaviors, the unexpected failures, sudden increase in loads, etc. Monitoring it, diagnosing, troubleshooting, all these issues is actually becoming more difficult and more complex because the complexity has made it such that there are no predefined, I would say, runbooks or procedures which can help us to diagnose this and then solve those issues quickly. And the data explosion is making this effect much more compounded, because now we have a lot of data which is generated by the machines, and it is no more a, I would say, a human scale problem. Across our customer base, we see most of our customers using the AWS infrastructure predominantly. Sumo Logic is a multi-tenant true SaaS platform. We have a breakup of customers from various diverse, I would say, set of cloud sources. But predominantly we have customers from AWS, followed by, I would say, multi-cloud customers, GCP, Azure, etc. And the architecture complexities actually continue to increase. We see that on an average, the number of applications adopted by customers is increasing. In average, they're around using 22 different AWS services, while there are hundreds of applications available out of AWS. And the top 10 services used to be the AWS are like the S3, Lambda, the EC2 instances, CloudTrail, etc. The architecture complexity actually increases because customers, they have multiple AWS regions, accounts, etc. Across our customer base, we see that 47% of our customers use 2 or more AWS regions, and we see a lot of customers use 2 or more AWS accounts as well. And all of this adds to a situation where we have numerous accounts. Getting a visibility across them becomes difficult because now each and every environment is separate. And in case you want to look into an environment, there may be multiple interfaces, multiple tools where you may have to log in and then check the details. So all of this makes a lot of data silos. the interactions between the applications, infrastructures, these have become pretty complex because there are microservices, we have the north-south traffic, we have the east-west traffic. So we have a lot of complex interactions which are happening between the applications. And troubleshooting these applications requires writing queries, bringing in the right set of data, and then tracking it down to find the root cause analysis of it. And let us agree that it is actually becoming hard to correlate all of the signals, aggregate all of this data, and then to derive meaningful insights out of it, if not maintaining very high levels of availability and uptimes. So the solution to this is where Sumo Logic has brought in the AWS Observability as a solution. So with the AWS Observability, we reduce your management overhead, where we provide a unified visibility for your entire AWS infrastructure. You have one menu, you have one screen under which you can look at all of your accounts. You can browse through your various hierarchies. You can look into all of your services from one single interface. You don't have to navigate between multiple tools, multiple interfaces. You don't have to build your mental map, etc. You can just get into the AWS Observability and you can see all your resources under one single window. And to enhance the capabilities of your monitoring, your troubleshooting, and then to resolve issues quicker, we have introduced the Root Cause Explorer. As the name says, we help you to quickly identify the root cause of issues, where you can quickly look at the, I would say, the points of interest, where you can look at things like the errors, the load. So you can quickly identify what is causing your application to face issues, and then you can quickly resolve them and then maintain very high levels of availability. We help you with out-of-the-box dashboards and out-of-the-box alerts. So with out-of-the-box dashboards, you don't have to look at building stuff. We provide you pre-built content. So all that is required for you is to set up the data collection inside your AWS environment. Once the data comes into the Sumo Logic platform, you can make use of the existing pre-built dashboards, contents which is available. And then we also help you with the out-of-the-box alerts. So you can look at the alerts, you can customize them to suit your environment, and then you are all ready to go with your AWS environment. Having said that, how do we set up the solution? It is pretty easy. We provide you a CloudFormation template. This particular CloudFormation template will install the necessary collectors to collect the data. And we use CloudWatch and CloudTrail predominantly to collect the data with the host metric source for the individual EC2 instances. Once we collect all this data, we run it through an enrichment cycle, and then we make the Explorer view of the dashboards available for you. So all of this content is pre-built, and we also provide you capabilities where you can check the smooth functioning of the CloudFormation template. You can run it as a prerequisite or a pre-check to ensure that you have all the necessary permissions, etc. And once the prerequisite check runs in, then you can go ahead and then you can get your data collection done using the simple CloudFormation template. Once you install the CloudFormation template, what are you going to get? You are going to look at an intuitive navigation across your various different accounts, various different namespaces, various different entities, etc. We provide you a hierarchical view where you can navigate from one level to the another, all out of a single interface. We provide you a lot of pre-built content. We have 40 plus out-of-the-box dashboards, and you can choose the alerts from CloudTrail, CloudWatch. You can set up alerts for the specific conditions you are looking for, apart from the out-of-the-box, I would say the alerts that we provide. There are 9 AWS services covered as part of the AWS Observability: EC2, ECS, RDS, Elastic Cache, API Gateway, Lambda, DynamoDB, Application ELB, and then the Network ELB. And there are more services getting added as we keep defining the product. Along with this, we provide a Root Cause Explorer, which is an anomaly detection capability. There is a lot of, I would say, the clustering algorithms which work in place. So these algorithms, they basically help you to group all the different anomalies together, and then they help you to identify if there are any errors, if there are any availability issues, latencies, bottlenecks, if there are any throughput issues, are there any errors which is seen over here, are any of your entities facing excessive loads, etc. While we go through the demo, I will show you how we integrate this particular interfaces. And on the AWS Root Cause Explorer, we support 14 services. All these services we have in AWS Observability are supported. And in addition, we support EBS, auto-scaling, SNS, and SQS as part of the root cause explorer. So these are the services which are supported as part of AWS Observability as well as the root cause explorer. So to make your life easier, we have actually come up with out-of-the-box alerts and content. So the questions that you have, like what should I monitor, which data set should I look into, what are the thresholds I should set and then manage it, how can I tell if a critical AWS service has reached its limit, whether it is performing, whether it's available. So these are the common questions that our customers have. And the answer to that is that we have come up with the out-of-the-box alerts. These are based on the industry best practices and then the recommendations from AWS. So these are installed as part of the CloudFormation template. So once you install the CloudFormation template, you can see the dashboards as well as the out-of-the-box alerts which are installed. These alerts are, I would say, disabled by default. You can enable the alerts which you would like to monitor, as well as you can customize it to your specific requirements. So having seen that, let's get on to the AWS live demo now. Once we log into the Sumo Logic interface, what we would be seeing is that you can click the new, and then I'm getting onto the Explorer-based view. So the Explorer-based view, I have the AWS Observability here. And under AWS Observability, I can see that there are various different, I would say, the AWS accounts configured in this particular demo setup. So I have a dev environment, I have a prod, I have a stage. So I can look into the all my different AWS accounts from this one single interface. So you can use the AWS alias. So you can give your name here, so it is easier for you to identify rather than giving a AWS account number over here. And under this, I can see I have a dev environment, pod, and then the stage. And then I'm going to get into the prod environment over here. The moment I choose a prod environment, I can see some dashboards coming up over here. And this is actually showing me the AWS account overview. So I can get into any of these accounts, dev, stage, prod, and I am choosing the prod account for this particular demo now. And I can see a high-level overview about my AWS account here. So I can see the activity, incoming activity locations. This is a geo view. The geo view is a graphical representation of the data. So the way this particular panel is built is that we go to the raw logs, pick up the IP address, and once we get the IP address, we do external table lookup, and we pick up the latitude, longitude, and then we plot this into a nice geo view. So it helps you to visualize the location from which you are getting this incoming activity. The AWS resource activity is shown here, like the various different activities across the various different resources that you have. And you can see high-level summaries about the services that we support as part of the AWS Observability. You can see the application load balancer here, the request served by ALB, API gateway, EC2, Lambda. You can see the RDS, couple of high-level summaries here, DynamoDB. You can look into the Elastic Cache, ECS, and then the network load balancer. So this is a high level, I would say, 30,000 feet view, and I can drill down and then get closer to my account details. So under this product account, I have two regions, the US East one and then the US East two. Now I'm going to get on to my US East one. So the moment I choose the US East one, I can see I am getting one level deeper into my infra now, and then I can see my account activity, the activity overview here, the AWS resource activities, and then I can see the services which are part of this particular region. So I can see the application load balancer here, request served by ALB, and I can see those honeycomb views here. So the honeycomb view, once I hover above the honeycomb view, I can see the metrics which are shown over here, and you can see various different colors showing up the status of the various different services. So you can see the API gateway here, again showing up a honeycomb view with the various different entities under the API gateway. You can see the EC2, Lambda, and I can see DynamoDB, RDS, ECS, a lot of resources over here. So from here, I can drill down to any of my, I would say, the namespaces, and then I can see more details about it. So for example, let's look into the AWS Lambda here. So what I have here is the AWS Lambda namespace, and I can see the various different functions names showing under my AWS Lambda namespace. And here I can see the uh, caller locations under the audit functions. So you can see the top AWS services which are using the Lambda functions here. You can see the top IAM users who are using the Lambda function. And the performance, I can see the invocations, errors, throttling, and on the top functions by duration. These are the Lambda functions which are actually taking more time. You can see the top Lambda functions which are actually taking up most memory, etc. And if I come down here, then I can see allocated memory versus used memory details, the most frequent function operations, etc. And all these metrics, they help us to understand the resource utilizations, the health of my various different function names, etc. I can drill down further from here to go into any of my function names. For example, I'm going to look at this after create. Now I have the details about the after create function. It shows the invocations trend over here, and I can look at my function durations. I can see the pass versus fail requests, all these details over here. And under this dashboards, I can get into usage analysis, error analysis, resource usage, performance trends, etc. Say, for example, let me get into my resource usage. This shows me the various different panels, which shows the recent request details over here, along with the details like the duration, build duration, the memory size, memory used, etc. You can find tons of metrics, which is helpful for us to understand my various different function names. So similar to this, I can get into any of my other namespaces. For example, I'm getting into my AWS EC2, and I can see my EC2 metrics overview here. So this shows the instances with my high CPU utilization, instances with high memory utilization, and you can see the honeycomb view showing us the health of the various different EC2 instances. And I can look at my memory, CPU utilization, summary statistics under this particular panel. From here, I can get on to any of the, I would say, the instances which are showing a resource constraint. Say, for example, I'm looking at this particular instance which is showing up in red. And if I hold my mouse over it, shows high CPU utilization over here. And if I click this particular entity, then I can see the entity overview dashboard coming up here, the panel coming up here. And here I can see the option menu options. I can look into all my logs for this particular instance. When we collect the data from your AWS infrastructure, we do a enrichment of all the data. We consistently tag all the data with all the different events, logs, metrics, etc. So we can easily pivot between logs and metrics. So if I want to look at all the logs of this particular entity, I can just click this, and then I can look at all my logs over here. I can go to the recommended dashboards for my troubleshooting, for my analysis of this particular situation, etc. Or I can get onto my individual instance as well to get more details. Say, for example, I can go to this region and then look at my high-level statistics summary. I can get into this particular account, or I can go to my individual instance as well. All I'm doing is just click this instance ID, and then now I'm taken to the specific instance over here, the EC2 instance. Now I am seeing the details for this specific instance here. It's showing up my metric summary over here for the specific host, and I can see tons of metrics which shows me the health of my, I would say, the instance. From here, I can go to my CPU utilization. I can check the CPU utilization. I can look at the user time, idle time. So I can check all of my CPU statistics here. I can get into my memory. So I can see all the information about the health of my node or my instance from these particular dashboards. So having said that, when we went through the Lambda, I noticed a couple of errors actually being seen in the Lambda function over here. So here we can see there are a lot of errors which are actually being seen. So there are around 7,000 plus errors over here. And a closer look at this shows the top error messages. And there seems to be some errors, connectivity errors, etc. on the function name called get billing info. And the panel below shows the successful versus failed request. If I go ahead and then disable this, I can see the get billing info facing a lot of failures over here. So to understand more about this particular function, I can simply go and then filter out this dashboard for this particular function name. So I can see there are a lot of options to filter here on the top of the dashboard. So I go here and I can simply type get billing info. The moment I start typing, I can see the auto populate options over here. I can simply click this. I don't have to copy paste. So I can simply choose this, and now I can see my dashboard is actually filtered for this get billing info. And when I come down here, I can see the database authentication error messages over here, and I can see there are no successes, all failed. And then the most frequent function operator shows me that for the get billing info, there are certain events like invoke, list functions, update function configuration, update function code, etc. So I see there are some changes which are happening, and changes are predominantly one of the sources for contributing to error conditions. So to take a closer look at it, I am actually going to my searches from here. So all I need to do is that just open up the menu option and go to the related search. So here I can see the searches. I can see the function name over here, my various different events, and then the count. I see the update function configuration shows there are some changes. So let me go and then look at what those changes are. I'm going to the raw log messages, and then I'm going to go to my event, and I'm going to look at my update function configuration. Now I can see that there is a filter which is automatically added to this query here, which says I want to filter it for the update function configuration. I can go ahead and then I can filter out for this particular condition, but I don't have to type this. I can just go to the field browser, and then I can choose my condition, and the dashboard filters will get automatically applied, and then you can see the relevant logs here. But taking a closer look at this logs, I can see that there are some changes which have been done onto the Lambda function here, update function configuration, and looks like there is a user, Mark Smith, has made some changes to the Lambda function over here. So now I can reach back to Mark Smith, and then I can find out what changes has been done here. And if the changes have not been successful, I can look at getting the function rolled back. So I can focus on bringing up the application back to production, right? So here we are able to see that from the single menu view, we are able to drill down to the specific function which is actually facing issues. And from there, we are able to get into the raw logs. And then we are able to find out the user who has made changes, which has actually caused this particular application to face issues. Right. So while we looked at the Lambda function over here, I would like to go to this the AWS region, and then I want to show you a use case where we can look at how we can deploy the root cause explorer to resolve complex conditions. So we are looking at the AWS region overview, and I see a couple of errors which are being seen for the ALB. So I am actually going to drill down a little bit from this region. I'm going to my application ELB. Now I'm looking at the ELB namespace, and that shows me my request locations over here. It shows me the latency, the 4xx code, 5xx code, etc. And then I see that one of my load balancers is actually facing 4xx, 5xx errors. I can see that over here. And if I come down a little bit, I can see the 4xx, 5xx errors for the last 24 hours. And then that shows me that I do observe for this particular load balancer, I am seeing some 5xx error over here. I can definitely see some spikes around this particular duration. The application load balancers, they are the front, I would say, customer facing interfaces. They receive the load, and then they balance it between the various different, I would say, the EC2 nodes, etc. The EC2 nodes, in turn, they may be talking to the databases, other applications. So there is a lot of complex interactions can happen when it comes to the applications. So to find out how to troubleshoot this particular scenario, I would like to go to the AWS, I would say, the root cause explorer functionality provided by us. So I'm now navigating to the region level, and from here, I'm actually going to choose the AWS region events of interest. And now I can see the interface coming up with the events of interest. And I'm going to choose a duration of around, say, for example, the last 24 hours. Now I can see the events of interest populating with data. I can see there are a lot of dots around here. The applications, the infrastructure, they generally face predominantly the issues like errors, availability issues, the latencies, bottlenecks, throughput, success, and then the various different load factors. I would say these are, I would say, the events of interest. We generally contribute to applications going bad, applications becoming unresponsive, etc. So if I hover my mouse over the various different colored bubbles here, I can see the color code showing the errors are shown as red over here. I can see the purple ones, which are primarily bottlenecks, etc. So let us take a closer, deeper look at the root cause analysis, root cause explorer. So I'm opening up the root cause explorer menu now. And here I can see the region and then the account details over here. And to filter out the data, I can automatically apply the filters recommended by the platform. And now here I can see the various events of interest, the various events of interest being errors, availability, latency, etc. So here we have the x-axis and the y-axis. The x-axis is the time. So this shows the time at which this particular, I would say, the event of interest has occurred. And the y-axis is actually showing the drift. The drift is how much the particular event that we see here is deviating from the normal. So here we are actually looking at the significant events of interest. By meaning significant events of interest, what we mean is that we are talking about interest, the events which are deviating from the normal behavior. Say, for example, if there is a increase with respect to certain metrics when users get into the office, it generally dips down in the afternoon and then increases by evening, then that is a normal behavior. We don't consider that to be a significant event of interest. But if the event is like deviating from the normal compared to the previous trend, then it definitely becomes an event of interest for us, because this is basically an anomaly that we are seeing over here. And here, for example, the EC2 errors we see here, the number of errors is 1,380%, much more than the normal that we see. Right. Similarly to that, you can see the drift is around 1,000% for 20 minutes for right throttle events. And you can see the various drifts over here. And the color codes actually help us to understand what this particular anomaly is all about. I would like to drill down this to a specific duration and time. So I'm going to choose a specific duration where I observed the ALB to be facing 5xx issues, which was somewhere around the 6 a.m. time frame. So I am actually going to choose this particular time frame to drill deeper into it. Now I'm actually looking at the specific duration over here. And here I can see the durations. The longer the duration, more I would say is the the outage of this particular entity or or event. The more I would say the drift is, it is more deviating from the normal, or more severe the particular incident is. So here we can look at the various different incidences which are clustered together. The clustered events generally show some correlation between them, because here we are looking at, say, for example, we are looking at the DynamoDB here. We're looking at a couple of hosts over here which are facing some issues. We are looking at the ELB here, which we noticed in our dashboard, which is facing issues of 5xx errors, etc. And then we can see the bottleneck which is being observed in the DynamoDB. So there is a very high possibility that all these events are related together. So I would like to go one by one. So I'm looking at the DynamoDB here, and then I am looking at the anomaly, which shows that there are a lot of throttle requests over here. And I see the drift is around 389% for around 10 minutes. And I can see the summary details over here for this particular anomaly. And it shows my metrics as well in this single window. And just above this incident, I see my ELB is actually facing issues. And I can see that my 5xx errors were very high. And there is a 722% drift for around 20 minutes. And I can clearly see the metrics panel that there is a sudden jump with respect to the 5xx errors in my ELB. And I also see the count for now versus a count one day before, which shows the errors we are facing now versus the normal behavior that we see on this particular environment. From here, I am actually looking at a couple of related events here. So I look at the bottlenecks faced by a couple of my EC2 hosts, and I can see there is a 983% drift for the CPU load. My hosts are basically experiencing very high level of CPU load, and I can see all these events clustered together. And to troubleshoot it, I can go to my infrastructure. I can look into all of this particular details. So we automatically cluster these events, the related, I would say the EC2 events, etc. And I can see the EC2 facing errors as well. The metrics clearly shows there is a sudden jump with respect to the number of errors. And you can see we automatically cluster all this together for your easier understanding. And if I come a little front, I can see the DynamoDB, which is actually facing issues. And you can see there is a sudden jump with respect to write throttle events, and it was observed for a 20-minute duration of time. So to find out why my DB is facing issues, I am actually going on to my related infrastructure, and then I can get onto any of these dashboards. But I would like to go to my events and then see what has actually happened in this particular DB instance. Now you can see the system automatically populating the duration for which the anomaly was observed. And I can see the event locations, errors, I can see information about all of them. And if I come down a little bit, then I can see there are some table events, and then I can see delete table, create table, but what interests me is this update table. Looks like some changes actually happening over here. So to get more details about this and to take a closer look, I'm going to open this up in the search window. And now my system is actually taking up the time duration automatically over here, and it is bringing me the related entries where I'm observing a couple of changes which are happening with respect to my table. And I can see there is an update table event which is happening. So I would like to go to the raw log messages to find out what changes are actually being done in this DB. So I can see here that there are a couple of events happening here, write capacity units 5, read capacity units 5, etc. Coming down a little bit over here, then I can see that there is a number of there is a write capacity units which has been decreased by the user Ankit Goyal. So looks like in this particular case, the number of write capacity units has been reduced by this particular user Ankit Goyal. So what should have happened is that the database capacity has been reduced, which is resulting in a chain event of the nodes facing issues, errors, etc., which results in the ALB, which is the customer facing the entity, which is actually showing up the 5xx errors followed by a throttling. Right. So the complex issues where we see there are various entities interacting with each other, it becomes important that we understand the overall picture, and then the root cause explorer helps you to cluster all the anomalies together, to analyze them together, so you can build a story of what could have happened over here. And now that we know that why this particular issue has actually happened, we can go back and then we can quickly look at fixing this particular issue. So having seen all of this, let us look at how we can create alerts so that we can become proactive rather than being completely reactive. So we provide out of the box alerts for you. So I'm getting into manage data alerts, and here you can see under the alerts, I have the AWS observability alerts, which are out of the box alerts. And here you can see various different alerts which are pre-built, readily available content for both logs as well as metrics. So these are the alerts which have been created by Sumo Logic with the industry best practices as well as the AWS recommendations. And you can look into this particular alerts and you can customize them as per your need. By default, we disable the status of all of these particular alerts. You can read the particular alert and then you can customize this as per your need. So for example, the Amazon ECS high CPU utilization alert, and you can see there are 3 types of alerts that you can set up: critical, warning, missing data. So I'm just going to edit this particular alert, and you can see the query which is actually covering it, and you can report for critical, and you can set up the synchronized settings. So when the situation resolves, we automatically alert you, and you can set up for warning as well as for the missing data. And you can set up a different type of alerts. So you can look at setting up, say, for example, alerts for, I would say, critical alerts. You can look at warnings, etc. And you can save this with a name. So once we set up all those alerts, then you will get notifications once the specific condition getting met. That's pretty much what I wanted to show you as part of the AWS observability solution from Sumo Logic. So we have a QR code here. To know more about the AWS observability solution, you can scan this QR code, and this will take you to the AWS observability solution page. We have clear documentation which shows how to deploy the AWS observability solution, as well as how you can get all these visualizations, how you can set up all your alerts, etc. Please feel free to reach out to us in case you have any questions. We can help you to set up a customized demo where you can explore the product. We provide a 30-day free trial. So you can subscribe to a Sumo Logic free trial. And in case you would like to explore the solution more, please reach back to us and we are happy to work with you. There is a Q&A button here in the menu options. Please raise your questions here, and then I can answer it to the best of my abilities. So I see a question here. The question is, how is the solution priced for the AWS observability? The Sumo Logic pricing is based on the amount of data that you ingest into the platform. It purely goes by the amount of data in the form of logs, the number of metrics that you send into Sumo. So we can provide you with a pricing depending upon how much data that your platform is going to generate. So reach back to us, and then we can work with you with respect to the sizing and then the pricing. The other question is it possible to create dashboards based on tags? How can I monitor service which is deployed in multiple regions using a single dashboard? So you can deploy the AWS observability for multiple regions. So let me quickly show you how you can do that. So under the Sumo Logic AWS Observability solution, you can look at the deploy and use AWS Observability. You can deploy to your multiple accounts as well as the regions. So yeah, the option to deploy this is still the same. I suggest you to look at the documentation, which clearly documents how you can set it up for multiple accounts, multiple regions, etc. The answer is yes, you can do that. That's pretty much what I wanted to show as part of the live demo today. Thank you for joining the webinar today. Wish you all a very good day. Thank you.